Inverse of tangent function. Does the inverse of tangent function exist? Let's find out with the help of the tangent function. First, look at the values of the tangent function for some standard angles. You can pause this video to read the table properly. From this table, we can say that the tangent function is not defined for odd multiples of pi by 2. So, the graph of the tangent function looks like this. In the graph, we can see that there is no curve for minus pi by 2, pi by 2 and 3 pi by 2 because the tangent function is not defined for odd multiples of pi by 2. Now let's check whether the tangent function is invertible or not. We know that if a function is a bijection, which means it is both 1, 1 and onto, then the function is invertible. First, let us check whether a tangent function is an onto function. As we can see that the range of tangent function is from minus infinity to infinity, that is real numbers. So, if we consider any point on the y-axis, we can clearly see that there is a corresponding point on the x-axis. So, the tangent function is definitely an onto function. Now let us check whether a tangent function is a one-one function. For this, we will use the horizontal line test. Draw a horizontal line passing through the curve of the tangent function. As we can see, the horizontal line intersects the curve at more than one point. This means that for each value on the y-axis, there are more than one corresponding values on x-axis. So, the tangent function cannot be a one-one function. And since the tangent function is not a bijection, so it is not naturally invertible. So how come we are studying inverse of tangent function when the tangent function is not naturally invertible? Confused? Don't be. There is a method by which we can make tangent function invertible, and this is what we are going to discuss now. As of now, we know that the tangent function is not naturally invertible because it is not one-one function. So, we can make it invertible by making it a one-one function by restricting its domain just like we did for sine and cosine functions. Let us understand how we can do this. As we can see that the domain of the tangent function is real numbers except odd multiples of pi by 2. And we know that the tangent function is not a one-one function in this domain. If you look at the graph carefully, you will notice that the curve is repeating itself at the distance of fixed intervals. So, if we consider only one curve, for instance in this interval, minus pi by 2 by pi by 2, we can see that in this interval, the curve of the tangent function passes the horizontal line test. This means that the tangent function is 1, 1 within this interval. And we have earlier seen that tangent function is always onto. This means that the tangent function is invertible in this restricted domain. Or in other words, we can say that the inverse of tangent function exists within this restricted domain. Actually, the tangent function is invertible in any of these intervals. So, the inverse of the tangent function exists in each of these intervals. The inverse of the tangent function is denoted like this, or it can also be denoted like this. We can read it as arctangent. This means that if y equals to tan x, then x equals to tan inverse y. If we look at the graph of the tangent function, we can see that the range of the tangent function is real numbers. So, the domain of the tangent inverse function will be real numbers. And the range of the tangent inverse function will be each of these intervals because the tangent function is invertible in each of these intervals. Corresponding to each of these intervals, we get a branch of function, and out of these branches, the open interval minus pi by 2 to pi by 2 is known as the principal value branch. Therefore, the range of the tangent inverse function is open interval minus pi by 2 to pi by 2. And this is how we write tangent inverse function. Thus, the inverse of the tangent function is defined as tan inverse y equals to x if and only if tan x equals to y, where x belongs to open interval minus pi by 2 to pi by 2 and y belongs to R. Let us now try to draw the graph of the tangent inverse function. As we know that if y equals to tan x, then x equals to tan inverse y. So, the graph of the tangent inverse function can be obtained by interchanging x and y axis of the graph of the tangent function. This is the graph of y equals to tan x. By just interchanging the axis, we can draw the graph of y equals to tan inverse x. This shaded portion of the curve from minus pi by 2 to pi by 2 is known as the principal value branch. Any value of tan inverse x within this interval is known as the principal value of the tangent inverse function.